This video introduces a TRINITY use case focusing on the virtualization of a robot cell with a real controller. In the use case, simulated hardware is represented in a real-time 3D environment, which can be used for demonstrating actual system functionality, training employees, virtual commissioning, and testing production operations for new parts. In this video, we will go through the following topics: how the virtualization of a robot cell with a real controller contributes to agile manufacturing, how could manufacturing companies benefit from this solution, and what kind of investments are required to utilize this solution. First, I will give you a brief introduction to Fastems, who is the owner of this solution. Fastems delivers intelligent factory automation solutions around cutting machine tools and related processes. Our main application fields are pallet and robotic automation. Now we will take a look at how the solution contributes to agile manufacturing. This use case aims to bring improvements to the operation of an agile manufacturing cell. The use case provides a way to easily simulate different production scenarios and layout changes offline without disturbing actual production. This means that changes can be tested and evaluated more often. It also gives the ability to familiarize new and existing employees to the system without disturbances. This way, the employees can be trained effectively and safely. The use case acts as an interactive learning environment that can be used whenever needed. The virtual system is identical to the physical one, so all skills learned with either one will carry over to the other. Now we will move on to the benefits of the solution. The proposed solution improves the agility and performance of the manufacturing cell by providing the means to evaluate new production operations and scenarios, as well as train employees separately from actual production. Overall, this means that less production time is lost to secondary tasks and that employees will be more competent at operating the system. It also provides a completely safe sandbox environment for testing and training. No physical harm can be done to the operator. This is especially useful for educational establishments, for example universities, who wish to use this use case as an interactive learning environment. Now let's take a look at the possible application scenarios. The application of this use case can be integrated to any company utilizing Fastems, Agile Manufacturing Cell, or any educational establishment looking to educate students about Agile manufacturing and the Fastems MMS software. Cell-level agility in machining and machine tending often calls for easy new part introduction. The MMS has many features that support this work, but using the virtual model as a pre-run platform has the additional benefit of proving the robot cycles, material capacities, and cell performance expectations already before the actual production begins. Next, we will have a brief look at the investments required to use this solution. Fastems will provide the user with the required operating panel called TouchOP and the virtual model of the production cell. In addition, the user requires a modern PC or laptop that can run the virtual model. The virtual model runs on the Visual Components platform. Additional screens can be used to better showcase the model. Finally, we will conclude this presentation by summarizing the key points. The virtualization of a robot cell with a real controller aims to improve the agility of modern manufacturing systems by creating a virtual counterpart of the actual production system. This way, changes can be made and evaluated without disturbing ongoing production activities. This also includes the training of operators. Similarly, educational establishments can utilize the use case to educate their students about the concepts and principles related to agile manufacturing. If you got interested and would like to find out more, See the following training material describing the system in more detail.